Dear students, now we try to learn definition of trace of a matrix. Trace of a matrix. In a square matrix, the sum of diagonal elements is called trace of matrix, denoted as the first two letters, trace, TR. So TR of A. See here, in the previous definition of diagonal elements, we discussed that diagonal elements exist only for square matrices. Diagonal elements exist only for square matrices. So, whenever we use the word diagonal elements, it must be a square matrix. Very simple definition. Sum of diagonal elements is called trace. If the matrix is named as capital A, then you have to denote it as trace TR of capital A. If the matrix is denoted as capital B, then you have to denote it as trace of B. So, according to the definition, trace means sum of diagonal elements. So, what are the diagonal elements? First row, first column, first row, first column, second row, second column, third row, third column. These three elements which I am showing in a box. So these three elements are diagonal elements. If you add these three elements, 1, minus 1, plus 6, if you add, the resultant is called trace. Plus 1 minus 1 gets cancelled. Plus 6, that is trace of matrix A is 6. So, the definition of trace of a matrix is sum of diagonal elements. Whenever and wherever you use diagonal elements, it must be a square matrix, because earlierly we have an idea about diagonal elements exist only for square matrices. So, whenever you use the word diagonal elements, it must be a square matrix. Sum of diagonal elements is called trace. Right. We go to the next definition. Diagonal matrix. Diagonal matrix. In a square matrix, if all the diagonal elements are non-zeros, in a square matrix, if all the diagonal elements are non-zeros, as I said, whenever you use diagonal elements, the matrix must be square matrix. So in a square matrix, if all the diagonal elements are non-zeros, which means not equal to 0, and remaining all elements are zeros, is called diagonal matrix. Let us discuss with an example. I have taken a square matrix named as A. These are the diagonal elements. These diagonal elements are non-zero. Diagonal elements. All the diagonal elements are non-zeros. 1 1 position. This is second row, second column position. This is third row, third column position. All the elements in these three positions are non-zeros. Remaining all elements other than these three must be 0. And all remaining elements are zeros, is called diagonal matrix. Instead of writing the entire matrix, simply we can also write it as diagonal, first 4 letters of diagonal. If the matrix is named as A, diagonal matrix A equal to 1, 2, 3, means the diagonal elements. In the matrix A, I am writing only the diagonal elements 1, 2, 3, first row, first column. This is the second row, second column. This is the third row, third column. Third row, third column. Only 3 elements. Remaining elements are all zeros. We try to write one more example. I name the matrix as B. I am writing a 2 by 2 matrix. -4, 0, 0, -5. 2 rows, 2 columns. 2 by 2 matrix. This is a diagonal matrix because diagonal elements, non-zeros, remaining elements are zeros. So this is a diagonal matrix. If you want to write in a simple manner, DIAG, capital B, matrix is named as capital B. First of all, you write first row, first column element. Next, second row, second column element. So what is the necessity of writing DIAG? If you didn't write DIAG here, you may feel that B equal to -4. If you didn't write DIAG, what will happen? B equal to -4, -5. It is like a row matrix. So to avoid the confusion, you have to write DIAG, which means diagonal matrix B. అంటే ఇక్కడ DIAG అని రాయకుండా ఓన్లీ B ఈక్వల్ టు అని రాస్తే చూడటానికి ఇది రో మ్యాట్రిక్స్ లాగా ఉంటుంది. అందుకోసం ఇది రో మ్యాట్రిక్స్ కాదు, స్క్వేర్ మ్యాట్రిక్స్ అని చెప్పటానికి DIAG అని రాసాం. డయాగ్నల్ ఎలిమెంట్స్ అని తెలియటం కోసం DIAG అని రాసాం. అంటే see here, DIAG of C equal to, there is a matrix 1, 4, 6. If I want to write expanded form of this matrix C, because matrix is named as C, this is first row first column element, 4 is second row second column element, 6 is third row third column element. These are diagonal elements. Remaining elements are zeros. So 0, 0, 0, 0, 0, 0. So this is the expanded form of this matrix, which is a 3 by 3 order square matrix. So diagonal matrix means, in a square matrix, if all the diagonal elements are non-zeros, remaining elements are all zeros, such matrix is called diagonal matrix. Right.